In each round of this series, I show you 3 cool demos, but one of the videos is fake. It's your job to tell which one that is. If you're new here, this show is called Two Truths and Trash, and this video is a marathon of all 8 episodes in Season 2, which comes out to a total of 25 rounds. Without further ado, here's the full second season of Two Truths and Trash. Good luck. 2 of the following videos are true while the other one is trash. Can you spot the fake? Round 1, let's begin. When a car accelerates forward, you are thrown backwards against the seat, just like this air balloon. However, a helium balloon in the same circumstance is thrown forward. Place some sand into a container, then grab some non-washable oil-based paint. Carefully but thoroughly mix the paint with the sand. Add more as needed. Once it looks thoroughly coated, leave it to dry overnight. When you come back to it, you've now successfully made hydrophobic sand. As you can see, the sand refuses to get wet and water beads on the surface. If life gives you lemons and you need to write a secret message to your friend, you're in luck because all you have to do is smear lemon juice on a piece of paper and let it dry. It won't look like there's anything on the paper, but when your friend heats up the paper carefully without burning it, the message will reveal itself. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought this video was fake, you'd be wrong. To understand why the helium balloon is thrown forward, think of the car like this container filled with water and a bit of air. When the car moves forward, the heavier water moves toward the back of the container, which pushes the lighter air bubble to the front. In a similar way, the lighter helium is pushed forward as the heavier air moves to the back of the car. Lemon juice also can be used to write secret messages. That means this wasn't a real way to make hydrophobic sand. I switched out this painted sand with some actually hydrophobic sand that I bought online. The painted sand just acts like boring old regular sand when you add water. To make hydrophobic sand that interacts with water like this, you need to coat sand with a super hydrophobic coating. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 2, which is a special round, a prediction round, where I describe what will happen and you will need to predict if it's true. Once I release them, these 2 balloons will race across the hallway. Because the blue balloon is bigger, it will propel itself faster and beat the smaller red balloon to the other side. I hot glued this roll of string to 2 glass cans. If I pull the string this way and at this angle, the object will roll to the left. Here's a cross-section of view in case you want to think about it. First, I'll pour hot water in one glass and cold water in another. Then I'll add red food dye to the hot one and blue to the cold so that it's easier to remember which is which. Next, I'll do this twice, but I'll stack the glasses such that only a thin piece of plastic prevents the water from mixing. In the first example, the cold water will be on top, and the 2 colors will mix almost instantly when I remove the plastic divider, and the whole thing will look like a single color. In the second example though, since the hot water is on top, the water won't mix outside of a bit of demonstration error, and you'll still be able to see red water on top and blue water on the bottom. You've seen all 3 videos now, pause to predict which one you think is wrong. Although it wasn't pretty, you can clearly see that the colors mixed when the cold water was on top, but didn't when the hot water was on top. Even minutes after the demo, you can clearly see the difference in colors. This device does roll to the left when I pull at this angle. The key is to think about what kind of moment is created on the object by pulling on the string. By drawing a force vector on the string and clearly labeling the point of contact with the ground, you can see that a counterclockwise moment is produced, causing the device to roll counterclockwise. If I instead pulled the string at this angle, a clockwise moment would be produced and the object would roll clockwise. If I pulled the string in such a way that the force vector goes straight through the point of contact, then no moment would be created, meaning no rotation, and the object would just slide to the left because the net horizontal force is pointing that way. That means this one was wrong. The smaller balloon is actually at a higher pressure, which causes it to have more thrust. Even if I give the larger balloon a head start, the smaller balloon still easily catches up. Here's a quick recap to help you follow before moving on to the next round. Now it's time for the final round, round 3. You might have seen from my other videos that a low temperature Stirling engine like this is powered by the heat from a hot beverage. However, if instead of hot water you fill the mug up with ice water, the engine will still work. After removing the tea from a tea bag, unfold it into a tube and place it upright on a table. Then carefully light the top part on fire. Hot air rises, meaning once the tea bag has burned enough that it's become light enough, it floats up, and away. We've all lived through the struggle of putting Pez candy into a Pez dispenser, but I recently learned a trick that could have saved me a lot of time. Place the full, unopened roll of Pez into the dispenser. Quickly slam the dispenser closed and the wrapper will tear off and exit out the bottom, leaving you to enjoy the candy. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought this video was real, you'd be correct. A low temperature Stirling engine only needs a temperature difference to work. Tea bags also do work like this. As much as I wish this was true, this video is fake. Here's a quick recap to help you follow before moving on to the next round. Next up, round 4. If you take some red cabbage, blend up some pieces, strain the juice out, and then place it into a test tube, you can check the pH level of things. Vinegar, which is acidic, turns a pinkish red, while baking soda, which is basic, turns blue. As you probably know, the pressure at the bottom of a swimming pool can feel quite high. In a cup of water, the pressure also increases with depth. This increased pressure increases the density. This causes an egg, which has a very similar density to water, to neither float at the top nor sink at the bottom, but rather float right where it has the same density. If you place a gummy bear in water and leave it for a few hours, when you come back it'll be substantially larger. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought gummy bears actually grow when soaked in water, you'd be correct. And red cabbage juice can be used as a pH indicator. That means this video is fake. Density does change with water depth, but it's very insignificant for only a few inches of water. I made the egg float by first dissolving a bunch of salt in water. This actually raises the density of water enough that the egg will float on top. Then I poured some unsalted water in, which the egg would sink in. It was stable for longer than I expected, and even when I poked it, causing some additional mixing, the egg would return to near its original position. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round 5. You can tell if 2 pairs of sunglasses are both polarized by holding them next to each other and overlapping the lenses like this, making sure they are in the same direction. Pour some hot water into a bottle. Then empty out the bottle and place a lid with the straw poking through it. Then dip the bottle into a bowl of cold water and watch as the water shoots up through the straw and partially fills the bottle. If you place grapes on the end of a chopstick and suspend it from above, you can use a magnet to slowly move the grapes back and forth without touching them. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you seriously thought grapes can be moved with a magnet, fantastic, because it's true. Grapes are diamagnetic, which is a much weaker form of magnetism than typical magnets, which are ferromagnetic. Nonetheless, as you can see here, it's not insignificant. This video is also true. As it cooled, a partial vacuum was created inside the bottle, which sucked up the water through the straw. That means this sunglasses video is fake. You need to rotate the lenses of the glasses perpendicular to each other to truly block out all the light. I made this look like it worked by masking the lenses where it overlapped and shading it black. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 6. If you add salt to water and dip 2 sharp double-sided pencils in the water, you can connect a 9-volt to the top of the pencils and bubbles will form on the submerged tips of the pencil. If you remove the abrasive strip of a matchbox, fold it and let it burn, you can pick up some of that residue and rub your fingers together, and this will create smoke coming off of your fingers. Place fresh corn into a sturdy bag, then seal it around the end of a strong vacuum pump. Creating a vacuum inside the bag removes the water from the corn, which shrinks the corn quite substantially. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. The bubbles that formed on the tips of the pencils were real and showcase electrolysis. Your fingers also do create smoke when you rub the burned matchbox. That means this video is fake. I just placed baby corn in the bag while you weren't looking. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round number 7. First up, take a jar of water, cover it tightly in saran wrap, poke a few small holes, and bring the water to a boil in the microwave. Next, quickly screw the lid back on. The hot water is not currently boiling, but if you place ice cubes on top of the jar and wait a few moments, the water inside the jar will start to boil. If you take tonic water that contains quinine, pour it into a glass, and shine a blacklight/UV flashlight on it, you'll see that it glows brightly. Here's a glass of tap water next to it for comparison. First, take a glass bottle full of water and cover it firmly with a shot glass. Then flip it over, keeping it sealed momentarily. When you start to lift the bottle up so it's no longer in contact with the shot glass can't do anything to stop the flow of water and the entire bottle drains. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. Tonic water that contains quinine actually does glow under the black light. Quinine is a fluorescent chemical. It absorbs light in the ultraviolet spectrum and then emits it as longer wavelength light that is part of the visible spectrum us humans can see. If you thought this video was fake, you'd be wrong. Placing ice on top of a jar cools/condenses some of the water vapor inside, which creates a partial vacuum. The hot water can boil at a lower temperature when it's at this lower pressure. I needed to make sure the majority of the gas inside the jar when it's sealed was water vapor. That's why I used saran wrap and poked holes. When the water was boiled in the microwave, the rising steam displaced most of the air. Anyway, that means this video was fake. When you actually do this demo as I originally described, the water does not spill out of the shot glass as the bottle is lifted. That's because atmospheric pressure is pushing on the surface of the water, opposing the weight of the water column. What I did in this example was use a glass drill bit and made a hole at the top of the glass bottle. This hole means that atmospheric pressure is now pushing on the top surface and bottom surface of the water, canceling each other out, and the weight of the water column causes it to easily spill out. Here's a quick recap to help you follow before moving on to the next round. Next up, round number 8. If you place a tennis ball in the freezer and leave it overnight, the cold makes it stiffer, meaning it will bounce a bit higher than a room temperature tennis ball when dropped from the same height. If you place a tangerine in a glass of water, it will float, but if you remove the peel, the tangerine will sink. If you place a large dry pine cone in water and wait a few hours, the pine cone will close and become quite noticeably smaller. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought colder tennis balls bounce higher, you'd be wrong. It's the opposite. The colder, stiffer tennis ball bounces substantially less high. Removing the peel of a tangerine releases some of the trapped air inside, which is why a peeled tangerine does sink. A dry pine cone also does close when soaked in water for an extended period of time, and it's pretty cool to see in a time lapse. Here's a quick recap to help you follow before moving on to the next round. Next up, round 9. If you place soap on the backside of a leaf that is floating on a pan of water, once the soap reaches the water, the leaf is propelled forward. If you've been subscribed for a while now, you know that soaking an egg in vinegar creates a bouncy yet somewhat fragile egg. However, if you take that bouncy egg and let it soak in maple syrup overnight, the inner yolk and whites also solidify into a squishy egg that can't be as easily popped and is more elastic. When you see the flame of a candle, it looks like a solid flame, but if you take a strainer and place it over the flame, you can see that these flames are actually hollow. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. If you thought soap on its own can propel a floating leaf, you'd be correct. Also, candle flames are actually hollow. That means this video was fake. Placing a bouncy egg in maple syrup overnight does sort of solidify the yolk, creating one of the most unpleasant textures in the world, but it doesn't make a rubber egg like this one. I just swapped this toy egg with the real egg while you weren't paying attention. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round number 10. First up, create a copper coil by wrapping it tightly around a tube. Then take a battery and place magnets on both ends. When you slide this battery through the copper coil, the battery accelerates through the coil until it reaches the end. If you pour a glass of sparkling water and add raisins, even though raisins are more dense than the water, bubbles form on the raisins which pull them up to the surface. Then the bubbles are released at the surface and the raisins fall again. This cycle continues, making a raisin lava lamp, so to speak. If you attach a ball pump needle to a drill, the drill spins fast enough to compress the air through the needle. It won't help you inflate a ball, which needs a much higher pressure, but it can inflate a balloon. You've seen all 3 videos now, pause to vote in the comments which one you thought was fake. The battery with magnets does actually shoot through the copper coil. Adding magnets to both ends extend the positive and negative terminals of the battery. If you connected the 2 terminals with a conductive wire, the circuit would be complete and current would flow. That's what's happening when it's in the copper coil. When current flows through a coil in this direction, it produces a magnetic field like the one shown here, with the north and south poles marked accordingly. To make it easier to see how the battery moves, I'll represent the magnetic field produced from current running through the coil as a magnet. If I just place both magnets with the north pole facing the same direction, the battery won't move, as you can see here. Since north and south poles of magnets attract, you can see that both magnets on the ends of the battery are pulled toward the center and the forces cancel out. However, if I flipped one of the magnets and therefore reversed the polarity, this would work. The south pole of the flipped magnet is now repelled away from the middle magnetic field, which means the net force is now pointing in a single direction, and the battery will move through the coil that way. If you flip the front magnet instead, you'd get the same thing but the opposite direction, and the battery would go that way. Anyway, raisins also do act like this in sparkling water, which means this video is fake. The whole thing was put in reverse, but I tried to add normal sounding audio. Here's a quick recap to help you follow before moving on to the next round. Next up, round number 11. If you pour out most of the contents of a can, you can have just the right amount of liquid such that the can will balance on its side just like this. If you hang a weight from two strings with different lengths that are tied at the same height, each string supports half the weight of the object. Ignore any small effect from friction of the weight touching the wall. A small motor like this can be powered by batteries to make it spin. However, a motor uses the same principle as a generator. So if I instead hook this motor up to an LED, I could spin the motor to make it act like a generator and light up the LED briefly. You've seen all three videos now, pause to vote in the comments which one you thought was fake. This can balancing trick does work and it's surprisingly stable even with small nudges. And a motor like this actually can be used to light up an LED. That means this video was fake. Two unequal length strings do not carry the same load. To see why without doing any calculations, imagine that both forces were the same, and therefore the vectors would be the same size. You know that the 5-pound weight isn't moving to the left or the right, which means the forces acting in the horizontal direction must be balanced. If you visualize the only two forces acting in the horizontal direction, you'd see that they would not balance. The only scenario where the tension in each string could be the same is if both strings were the same length. Then the forces in the x direction would balance. Here's a quick recap to help you follow before moving on to the next round. Next up, round 12. This is an anti-gravity humidifier. This device uses a strong vacuum pump to suck water up from a bottom reservoir. And the way it's able to do so slowly and a single drop at a time is what makes it look so cool. A piece of plastic shaped like this can create the illusion of a hologram by placing it on top of your phone and playing a holographic video from YouTube. If you're stranded and need to make a fire with a battery and a gum wrapper, you're in luck. A gum wrapper like this one conducts electricity. If you rip off some of the wrapper to make a thinner strip, this thin part has a high enough resistance to generate enough heat to catch the gum wrapper on fire. You've seen all three videos now, pause to vote in the comments which one you thought was fake. If you thought this video was fake, you'd be right. It looks like the water droplets are slowly being sucked upwards and almost appear suspended in the air. However, looking at this device in slow motion shows a different story. Water droplets are falling from the top to the bottom and flashes of light are periodically lighting up the stream. The flashes are happening so quickly that your eyes in real time can barely notice them. Here's a comparison between 3 consecutive flashes. As you can see, it seems like the drops stayed in the same position or perhaps even shifted up slightly, even though they really have just fallen. If you instead take 100 screenshots of consecutive flashes and play it as a GIF, you can see how this creates the illusion of upward flowing water. Here's a quick recap to help you follow before moving on to the next round. Next up, round 13. If you try to get hand sanitizer while wearing a black glove, the automatic dispenser will not detect your hand and won't dispense hand sanitizer. There are no documented cases of hippos ever going into the ocean. If you put a small amount of water into a can, bring it to a boil, and then flip it over onto a pan with ice water, the can will be crushed. You've seen all three videos now, pause to vote in the comments which one you thought was fake. If you thought this video was fake, you'd be wrong. These hand sanitizer devices use an infrared sensor. When an object is underneath, the infrared light hits the object and bounces back to the sensor. The color black is really good at absorbing light, meaning light does not reflect off your hand and the sensor won't know it's there. This experiment also works, and here's what it looks like using a thermal camera. When you flip the can over into the pan of ice water, the hot water vapor inside the can is rapidly cooled, which decreases the pressure, creating a partial vacuum that crushes the can. Although hippos are primarily freshwater animals, there have been a few very rare circumstances where hippos were spotted in the ocean on the coast of sub-Saharan Africa. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round 14. If you take some toothpaste, a spoonful of cornstarch, and iron filings, mix it and add some water and then leave it in the sun to evaporate the excess water, you'll be left with a gooey putty that can be manipulated with a magnet. If you clink a carbonated beverage from above, the beverage will spill over. If you add milk to Coke, the Coke reacts with the milk and causes the milk to curdle. After a few hours, the drink will be clear enough that you can see through it. You've seen all three videos now, pause to vote in the comments which one you thought was fake. If you thought this trick was fake because of this horrible jump cut, you'd be wrong. This trick does work, and if you fall victim to this by an evil friend, you should also know that you can immediately stick your finger to block the opening, which prevents the disaster. Or if you want revenge, you can cover only part of the top and spray it back at them. This was not a real way to make magnetic putty. I just replaced the concoction with the magnetic putty that I got at the store while you weren't paying attention. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 15. A Venus flytrap is called a carnivorous plant because it needs to eat insects to survive. Each trap needs around one housefly-sized insect per year. A plant like this is called a resurrection plant. A resurrection plant can go without water for around 7 years. Then, once you soak it in water, the plant unravels and starts to turn green in a single 24-hour period. This cilantro plant is growing towards the sun. If you rotate the plant will move towards the light within just a few hours, and this time lapse was definitely not taken over multiple days. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. A resurrection plant can go without water for around 7 years, and here's what it looks like when it's rehydrating in a 24-hour time lapse. Venus flytraps technically don't need insects to survive and can function like a normal plant. However, I will add that I later learned from the comments that this one was a bit misleading since they often grow in poor soil conditions without enough nitrogen, so they get that from eating bugs. Here's a quick recap to help you follow before moving on to the next round. Next up, round 16. First up, take a graphite pencil and draw 2 thick lines. Then tape the positive and negative terminals of a 3-volt battery to the lines. Close the switch on the battery holder, and now if you complete the circuit with an LED facing the correct way, the LED will turn on. Next up, you need hot water and some dry ice. If you have a large enough potential difference from the near boiling water to the really cold dry ice, the electrons will flow through the wire and light up the LED. Lastly, grab some oranges and connect them all in series using these copper and zinc metal prongs. Then when you complete the circuit, the LED will turn on. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. Graphite does conduct electricity, so this is a real way to light up an LED. Oranges in this configuration can also be used to light up an LED, although it wasn't very bright, which is why I needed to turn off the lights. That means this video is fake. A temperature difference like this does not cause electricity to flow from hot to cold. I simply turned the LED on using a power supply, masked the bright LED, and overlaid it back onto the original clip. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round 17. First up, take some very viscous vegetable glycerin and pour it into a bowl. Then put a bowl of water inside to create a thin layer of glycerin on the outside. I added chip clips so the middle bowl stays roughly concentric. Then add some food dye to some other bowls with glycerin. Then place a few color streaks into the thin layer of glycerin. When I spin the middle bowl, the colors appear to mix, but because the glycerin is so viscous, I can spin the bowl back and the colors will separate into their individual streaks. Next up, take an erasable pen and write on a sheet of paper. The ink of these pens is thermochromic, so it changes color with temperature. That means if you use a heat gun, you can erase the ink. Next up, take a small piece of plasticine and stick it to a plate. Then you need 2 matches. Break off the first match to make it slightly shorter, and then rest the second match on the first one like this. Then after you light them and let them completely burn, the matches will become stuck at the tip and the second match will be lifted off the plate, as you can see here. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. The viscosity of the vegetable glycerin does allow for the food dye to mix and then return to its original position. And heat guns are hot enough to erase the ink of an erasable pen. That means this just kidding, it's the long-awaited none of the videos are fake option. Here's a full clip of what happens when both matches are burned, and as you can see, the second match is lifted off the plate. Here's a quick recap to help you follow before moving on to the next round. Next up, round 18. First up, you hopefully remember from last round that the erasable pen can be erased with the heat gun. But if you take a block of dry ice and place it on the erased ink for a few moments, the ink will return. Next up, take some clear glue and empty it into a bowl. Then add a bit of baking soda and mix it up. Next, add some food dye to change the color. Lastly, add a bit of contact solution and mix it once again. And now you'll be left with some fun slime that can be squished and stretched like this. If you take a very viscous substance like this syrup and add it to a container, you can place a ping pong ball in this container, and when you drop it, the ping pong ball will shoot up. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. Ink from an erasable pen can be brought back by cooling it with dry ice. And this is a real way to make slime. That means this video was fake. I tried my absolute best to edit out the water and the sound of the splash from this original clip. But no, it will not work with a viscous substance like syrup. However, the ping pong ball does shoot up when the container is filled with water. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round 19. If you take a charger block and push it against certain painted walls, it will just stay up on its own. This also works with other objects with flat surfaces like these pencils. If you take sunscreen and rub it into your hands and then use a thermal camera, you can see how the sunscreen blocks harmful infrared waves from the sun and prevents you from getting sunburned. First, take 5 bowls and fill every other bowl with water. Add red food dye to one, yellow to another, and blue to the final one. Mix them so they look like this. Then take some paper towels and fold them into 4 long, thick strips. If you connect the water bowls to the empty bowls using the paper towels and wait a few hours, the dyed water will travel up the paper towels and mix into the empty bowls, creating bowls of water with new color combinations. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. If you thought you couldn't stick random objects to the wall by sliding them strongly, you'd be wrong. Why does this work? Well, there's some debate, but I think the best explanation is that the friction heats up the paint, making the paint stickier. Using a thermal camera, you can see that there's definitely a heat spot when you take the object off the wall. This experiment was also real, and here's a cool time lapse of it happening. That means this video was fake. A thermal camera measures temperature using the infrared spectrum. To get this shot on the thermal camera, I just held a block of ice for a little while to make my hands very cold. Here's a quick recap to help you follow before moving on to the next round. Next up, round 20. First up, take a cereal that is high in iron and add some water and blend it up. Then take this mixture and put it into a plastic bag and close it. Then take a strong neodymium magnet and slowly rub it all over the outside of the plastic bag, trying to expose the magnet to as much cereal as possible. If you're careful enough, you can see the iron pile up and you can move it around with the magnet. If you take a multicolored balloon like this and a magnifying glass, you might have a hard time popping the balloon when you focus the sun on the yellow part of the balloon, depending on the strength of the sun and the magnifying glass. However, if you focus on the black part of the balloon, it will pop much more easily. If you flush a toilet in the northern hemisphere, it will rotate counterclockwise, but if you're in the southern hemisphere, it'll rotate clockwise. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. If you thought I just poured iron filings into this bag of cereal because you saw it here on the counter, you'd be wrong. This is a legitimate way to see the iron in cereal. And here's what it looks like under a microscope. This video is also real. Darker colors absorb more light and therefore get hotter. Here's what it looks like using a thermal camera. Although the direction a hurricane spins depends on the hemisphere, the direction your toilet spins does not, and it's just based on which way the jets are facing. Here's a quick recap to help you follow before moving on to the next round. Next up, round 21. If you drop large, dense objects off of a boat into a pool of water, the water level will technically rise slightly due to the object displacing water. Next, a regular air balloon is quite vulnerable to an open flame and pops as soon as it touches. However, if you add a little bit of water inside the balloon, the water will prevent the balloon from popping and can even touch and extinguish the flame. Lastly, start by getting some ice and pouring it into an ice chest. Then add some water to be able to mix it more easily, and then add a ton of salt. Let this mixture sit for a while so that the temperature stabilizes at the mixture's new melting point, which because of the salt should be a few degrees below 0. Next, add a few bottles of purified water submerged in the mixture and leave them for a few hours. Then if you carefully take one out, open it and pour it onto an ice cube, the ice will instantly freeze and make a mound of slush. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. This experiment is legit and in my opinion super cool. Instead of pouring the water, you can also whack the bottle and watch as the water instantly freezes inside. These experiments work because the water has been super cooled to below its freezing point, but hasn't actually turned into a solid yet. Then you can trigger it into changing phases with either an abrupt jolt or by adding some already solid chunks to provide sites for nucleation. Supercooling is not unique to water. Gallium should be a solid metal at room temperature because its freezing point is just above room temperature. However, as you can see here, I poured warm gallium into this mold and let it cool overnight, yet it was still a liquid the next day. It was only after I added a few chunks of solid gallium that the rest of it froze. It's also true that a balloon with water won't pop on a small candle flame. That means this video is fake. Rather than increasing the water level, dropping a dense object off of a boat technically lowers the water level. This might seem unintuitive, which is why I made a separate video explaining this using an exaggerated demo. I'll put a link to that video in the description. Here's a quick recap to help you follow before moving on to the next round. Now it's time for round 22. First up, grab a sheet of paper and write something on it. Then place it into a Ziploc bag and seal it. Then draw something on the outside of the bag in Sharpie. When you place the bag into the water, you can see that the words written on the paper will disappear when viewing from this angle, but the stars drawn on the outside of the bag do not disappear. If you take a beaker of water, weigh it on a scale, and then carefully dip your finger in the water, you'll see that the reading on the scale does not change because your hand is holding up the weight of your finger, meaning there's no additional force transferred to the scale. If you blow bubbles, they'll pop almost immediately when they touch your hand. However, if you wear cotton gloves, you don't need to make any modifications to the bubble soap, and the bubbles won't pop nearly as easily, and you can bounce the bubbles repeatedly. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. Wearing cotton gloves does help prevent bubbles from popping. If you thought this video was fake, well, you'd be wrong. From this angle, the words on the paper do seem to disappear. This is due to the way light refracts through the plastic bag and the water. If you look at it from a different angle, you can see that the words are clearly still there. That means this video is fake. The reading on the scale does rise when you dip your finger in the water. Your finger is displacing water, and the buoyant force acting on your finger acts equal and opposite on the water and therefore the scale. I simply masked the reading on the scale to make it look like it didn't change. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 23. If you take a piece of graphite pencil lead and place it across the terminals of a 9-volt battery, you can touch a match to the graphite and the match will light. If you drop food dye into a glass of water, the food dye slowly sinks and mixes with the water like this. However, if you place a bunch of sugar in the water and stir it up to dissolve it, now when you drop food dye into the glass, the food dye will rise back to the surface and not immediately mix like before. If you place 2 inflated balloons of slightly different size on both ends of a PVC valve, when you open the valve, air will flow from the larger balloon to the smaller balloon until there's the same amount of air in each. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. When the graphite shorts the 9-volt battery, the graphite gets hot enough that it can ignite the match. When dropped into denser sugar water, the food dye does rise back to the surface instead of mixing right away. Here's a view when dropping the food dye from even higher, and it's pretty cool to see. That means this video is fake. The air actually goes from the smaller balloon to the larger balloon when the valve is open. That's because the pressure does not simply rise as the balloon is inflated, but rather looks something like this. So in this example, the smaller balloon is actually at a higher pressure, and since air flows from higher pressure to lower pressure, when the valve is opened, air flows from the smaller balloon to the larger balloon until both pressures are the same. If you take a large inflated balloon and an empty balloon and do the same thing, what's going to happen? Pause to think about it based off this graph. Since the larger balloon is at a higher pressure, air will flow to the deflated balloon until that balloon has the same pressure. And as you can see, the deflated balloon barely even inflates before the pressures are already the same. This whole concept might seem surprising, but it makes sense once you remember how blowing into a balloon is most difficult at the beginning. Here's a quick recap to help you follow before moving on to the next round. Next up, round 24. If you take a straw that has been cut to this size and place it between 2 glasses, one empty and one full, the water from the full glass is siphoned to the empty glass until the water level is equal for both. These nails are not magnets, but if you take a strong magnet and place a nail on it, you can string together multiple nails without them falling. Next up, take a Brita and place it next to the sink. You'll notice the faucet nozzle doesn't stay up, and you might think I need to sit there and hold the faucet as I fill it up. However, if I turn the faucet on, the thrust from the water shooting out provides enough force to keep the nozzle up. Then when I'm done, I turn off the water and the nozzle automatically falls back into place. You've seen all 3 videos now. Pause to vote in the comments which one you thought was fake. If you thought this video was fake, you'd be wrong. You totally can chain multiple nails together using a magnet. Also, turning on the water does allow me to fill up my Brita without me having to hold the nozzle. This is the second interesting phenomenon that I've observed with the sinks in my apartment, and it was simply too interesting for me to not include. Anyway, if you thought this video was fake, well then you'd be right. This is not a real way to siphon water, and nothing happens if you place this between the 2 glasses. You have to dip the straw upside down underwater to fill up the straw, and then quickly but carefully turn the straw over. When the water on the right side of the straw starts to fall, it's not just going to leave a vacuum behind, but rather the negative pressure instantly pulls the water from the left side along with it. And this flow continues until the straw is either no longer submerged in water or the water levels are the same. That's how a real siphon works, but to make it look like it worked, I did some careful masking, and being that I'm not a great editor, I was pretty happy with the result. Shout out to Definite Articles for submitting the idea to chain nails together with the magnet. Here's a quick recap to help you follow before moving on to the next round. The final round, round 25, is a bonus round brought to you by my 2 Truths and Trash Science trivia deck. It's got 50 new rounds in the same format as the show, so let's do an example one. A. Decompression sickness caused by divers returning to the surface too quickly is commonly referred to as the bends. B. Vitamin A was the first vitamin to be discovered and named, followed shortly after by vitamin B. C. The mammal with the highest blood pressure is the giraffe. Pause now to vote in the comments, and while you think, I wanted to point out that if you're interested in purchasing a deck, you can go to twotruthsandtrash.com or use the link on this video. It turns out that despite being the first letter in the alphabet, vitamin A was not the first vitamin to be discovered, but rather vitamin B1 was found slightly before it. I've already posted the Season 1 marathon, so check that out if you haven't, and the Season 3 marathon will be coming out shortly. Then the Season 4 premiere will be out after that. I hope you've enjoyed this series thus far, thanks for watching to the end, and I'll see you next time.